In this problem, we need to use the present value formula, and I've written that below, to determine the amount to be invested now, or the present value needed. So we want to calculate the present value, which is really just the same thing as the principal. So present value, or the principal, really the same thing. Okay, so to calculate that, we're going to look at the desired accumulated amount, that's A, and multiply that by 1 plus R, which is our rate, divided by the number of compounding periods, and that's going to be the number of compounding periods in 1 year. In this case, that's 12 because it said it was compounded monthly. So this tells me that n equals 12. And then the time is t. So that's going to be the 13 years. So really what this exponent tells me, the n times t, is how many times the value is going to be compounded, or the interest is going to be compounded over the course of the investment. And we have a negative exponent there because we're actually doing this kind of backwards from what we usually do. We start off with how much is being invested, and we multiply it by 1 plus r over n to the positive nt, and that gives us a. So it's a negative exponent because we're going in reverse. So what do I know? I know that the amount that we want to accumulate is $80,000, and I'm going to multiply that by 1 plus. The rate is 2.1%, so I'm going to write that as 0.021, and that's over the number of compounding periods in 1 year, so that's 12. And then I'm raising that to the negative 12, which is n, times 13, which is t. So when you put this into your calculator, you may need to put that exponent in parentheses in order to have it all multiply together and be the exponent. If you have difficulty with that with your calculator, you can multiply that first and get a negative 156. So now I put that into my calculator, and let's see. Whoa. So I've come up with $60,901.95. And so that is what we got for that. That's the end of that problem.